These are some problems in the chapter of continuity. Actually, we have the definition of continuity is limit a function is continuous at x is equal to a if limit of fx x tends to a plus is equal to limit of fx x tends to a minus is equal to fa. Function fx is continuous at x is equal. This is definition 1. This is definition 1. But there is another definition, that is definition 2. That is limit of fx x tends to a is equal to fa. This is definition 2. And we should know when this is applicable, when this is applicable. The definition 1 applicability of definition 1. When the function is first for modulus function, absolute value function or modulus function. 2. In case of greatest integer function, next conditional function, and some functions where 1 by x is there, and at that case x tends to 0, and it is a special case where 1 by x is there and x tends to 0. Now, if except these 4 cases, the definition 2 is applicable everywhere. It is very important for the examination where you will introduce the definition 1 or definition 2. Here I am giving some problems, and for each problem I will tell you in which definition, either by definition 1 or by definition 2, you will do the problem. Mark it. Now all these 5 problems will be solved by definition 2. Then I will tell other problems which will be solved by definition 1. Now these problems, here see, here there is no conditional function, no greatest integer function, no absolute value function is there from 1, 2, 3, 4, 5 problems. So we will apply the definition 2. So I am writing here definition 2, that is a function fx is continuous at x is equal to a if limit of fx x tends to a is equal to fa. Now first bit. So I am telling limit of fx x tends to a. It is called the limiting value. Limit x tends to a. So here fx has 2 values. Here x square minus a square by x minus a, and some focus problem is there. Okay. Now I am telling you again. The function fx is continuous at x is equal to a if limit of fx x tends to a is equal to fa. Here first, in the first bit, fx has 2 values. One is x square minus a square by x minus a, and this is fx has value this for the condition x not equal to a, and fx is equal to 2a when x is equal to a. Now limit of fx x tends to a. Here I am writing fx in place of fx. What I will write here? Fx has 2 values. This value condition x not equal to a. This value when x is equal to a. X tends to a means means x is going towards a. X is not reaching a. That means x is not equal to a. X not equal to a. So in place of fx, I will write this one or this one. Tell me. I will write the upper one. That is what? X square minus a square by x minus a. Now it is what? Limit x tends to a. X plus a into x minus a by x minus a. So I cancel x minus a. Why I cancel? As x tends to a, x not equal to a and x minus a not equal to 0. So it is what? So it is limit of x plus a when x tends to a. Now the value is 2a. Now what is functional value? It is limiting value. Now I want to find the functional value. fa. It means the value of function. The value of function when x is equal to a. And clearly it is given that when x is equal to a, the value of the function is 2a. It's 2a. Here the limiting value. Here limit of fx, x tends to a is equal to fa. This implies the function is continuous at x is equal to a. Next you will see then problem number 2. Here it is a condition, but it is my aim is not conditional function. In my opinion, is less greater condition. Here it is not less greater condition. It is equal not equal condition. In equal non-equal condition, you will apply this definition. But in less greater condition, you will apply the definition 1, left hand limit, right hand limit, functional value. Okay? Okay. Next we will discuss the second bit. Second bit what? Second bit here, it is conditional, but what condition? Is there any less than greater than condition? No, absolutely not. The condition equal condition, not equal condition. So you will apply this definition again. What is this? The limit of fx, x tends to 0 is equal to limit x tends to 0. What is fx? Now fx is sine 2x by x. Why I am taking this function? As limit as x tends to 0, it implies x never equal to 0. I am telling one example. मैंने एक बार एक रिक्शा में जा रहा था. इस टाइम में मैंने रिक्शा को बोला ए रिक्शा विल यू गो, तुम जाओगे क्या? उन्होंने बोला हाँ मैं जाऊंगा. तो मैंने बोला ओ जाओ. जाने का क्या तकलीफ है? मतलब x tends to 0 means it is going towards 0, but it is not exactly at x is equal to 0. It may be x, it may be 0 plus or it may be 0 minus. It is not exact at the point 0. So x not equal to 0. Look at here, limit x tends to 0 sine 2x by, here I am telling 2x multiplying 2 and dividing 2. We have one formula, limit sine जितना by उतना tends to 0 वो 1 हो जाएगा. मतलब here x tends to 0 means 2x tends to 0. X tends to 0 is equal to, is same as 2x tends to 0. Now sine 2x by 2x, 2x tends to 0. This is a constant, so this will come outside. Limit 2x tends to 0, sine 2x by 2x. So value is what? 2 into 1, that is 2. This is a functional value. This is the limiting value. Now the functional value is what? f0. Means the value of the function when x is equal to 0. The value of the function when x is equal to 0. It is clearly given, it is what? 2. Now the limiting value of fx when x tends to 0 is equal to functional value. This implies the function is continuous at x is equal to 0. This formula is important for this problem. You have to remark it. Next we will teach the chapter. Next we will teach the problem fx is equal to this much. Third page. Limit of fx x tends to 0 is equal to limit x tends to 0 fx means x tends to 0 means x not equal to 0. X not equal to 0 means what? Here it is written 1 plus 2x whole to the power 1 by x. And we have one formula for limit. Limit 1 plus jitna to the power 1 by utna tends to 0 is equal to e. Here there is a formula. So what we will do here? Limit x tends to 0 means 2x tends to 0. 1 plus 2x whole to the power 1 by 2x. Let us take its square. So 2 cancel. So what I am doing here? Now this limit is applicable for this bracket. So I am introducing it to it. So it is what? Limit 2x tends to 0, 1 plus 2x whole to the power 1 by 2x whole square. It is just what? See, it is box tends to 0, 1 plus box to the power 1 by box. Now clearly it is what? E. The value is e square. Now what is the functional value? Functional value is what? f0. f0 means what? Value of the function when x is equal to 0. The value of the function when x is equal to 0 is equal to also e square. Now limit of fx x tends to 0 is equal to f0. Equal to f. Implies what? The function is continuous. Is continuous at x is equal to 0. If it is EQ, then f0 is equal to EQ. E square is not equal to EQ. So the function will, at that time the function will not continuous. Okay. Now we will discuss about this function. Fx is equal to what? X sin 1 by x. If x not equal to 0, 0 when x is equal to 0. And here it is very important. At what point you will discuss? You will discuss here at x is equal to 0, at x is equal to 0, at x is equal to 0, at x is equal to a. That is important. Next problem. In exam, you have to write this so that if you will not write this, you will not get marks. I feel. Suppose fx is equal to limit x tends to 0. 4. What is here? X sin 1 by x. What you have to write here? Fx. In place of fx, you have to write what? X sin 1 by x. Why it is x sin 1 by x? It is because x tends to 0 means x not equal to 0. X not equal to 0 means you have to write here x sin by 1. X sin 1 by x is here. It is limit x tends to 0. X into limit x tends to 0 sine 1 by x. Here is some problem is there. Some of my friends are not are telling this is not the good way, because they are telling sine 1 by x, they are telling to apply this formula in sandwich theorem. But here it is clearly a correct thing is we separate it because it is not in the form of 0 into infinite form. That's why we can separate. If it is in 0 into infinite form, then we cannot separate it. Here the value is 0 into, what is this? We have to know. When x 0, it is sine infinite. And the value of sine infinite is a value which lies between minus 1 to 1. So I will write a value lies in minus 1 to 1. Matlab kya? Means this limit has a value which lies in between minus 1 to 1. Clearly it is not infinite. Mind it. 1 x tends to 0, 1 by x. Don't think it is infinite, because in front of it sign is there. Its value is minus 1 to 1. So what is its result? Result is 0. So its limiting value is 0. Now what is its functional value? Clearly look at here. The functional value, tell me. What is this? f0 means the value of the function when x is equal to 0 is, here it is given 0. So limit of fx x tends to 0 is equal to f0 implies the function fx is continuous at x is equal to 0. Next we'll read the problem number 5. Problem number 5. Look at here. Here what is the x not equal to 1, x is equal to 1. It is also a conditional function, but it is not less than greater than conditional function. It is simply a conditional function. What is this? Fx limit x tends to here 1. Because it is telling you to discuss the function about x is equal to 1. Limit x tends to 1. What we will write? Fx, it is x square minus 1 by x minus 1 is equal to limit. Here there is one formula also there. You can write or you can apply x to the limit x to the power n minus a to the power n by x minus a. You can apply that formula. Also this is another formula. Limit x tends to 1, x plus 1 into x minus 1 by x minus 1. You cancel it. Now it is limit x tends to 1. You have to write as x tends to 1, so x not equal to 1. Here you cancel x minus 1 as x minus 1 not equal to 0. It is x plus 1 and the result is 2. Next, what is its functional value? Functional value. What is its functional value? Matlab value of the function when x is equal to 1. It is 0. Now you can write in exam this is functional value, this is a limiting value. You can write also, no problem. Now here limit of fx x tends to 1 is not equal to f1. This implies the function fx is not continuous at x is equal to 1. Okay. This is number 5. Sorry. This is number 5. Okay. Now note it down. I will teach you next problem 6 to 10 on the next. Next we will discuss the problem of fx is equal to sine 1 by x when x not equal to 0 and fx is equal to 0 when x is equal to 0. Now limit of fx for the problem number 6, limit of fx x tends to 0 is equal to limit of x tends to 0 of sine 1 by x. Now exactly look, when x tends to 0, sine 1 by x means what? Sorry, I am telling you about the problems of 6, 7, 8, 9, 10. First observe what types of problems are here. Here it is absolute value function, modulus function. So we have to apply the formula. Limiting value, we have to find the left hand limit, then right hand limit, then the functional value. Here what? Here it is a bracket function. So in this problem also we have to find the left hand limit, right hand limit and the functional value. Here look at here. Here is the bracket function or the greatest integer function. We have to apply the left hand limit, right hand limit, functional value. Here look at this point. It is 1 by x, x tends to 0. I have given a special case for 1 by x, x tends to 0. And here also 1 by x is there and x not equal to 0. Means x tends to 0 of 1 by x is here, x tends to 0 of 1 by x is here. 1 by x. So we have to first know what is the limiting value, limit of 1 by x when x tends to 0. Many students are telling it is infinite, but it is absolutely wrong. It is never equal to infinite. As see the graph of y is equal to 1 by x. Here it is what? Here the graph of y is equal to 1 by x. You have already read the chapter of chemistry, the Boyle's law. Boyle's law means volume is inversely proportional to pressure, or pressure is inversely proportional to volume. In that case, PV is equal to constant. Suppose V is equal to K by P. Suppose I am telling you K is one constant. Suppose V is equal to 1 by P or P is equal to 1 by V. In this case, y is equal to, similarly, like that we have seen y is equal to 1 by x. One of the example, y is equal to 1 by x. Like Boyle's law, you have seen the graph of volume and pressure, and graph of Boyle's law is like this. Here I am telling you the graph of y is equal to 1 by x. Remember, here indirectly xy is equal to what? The product of two numbers whose result is 1 means two cases are there. Case 1 x positive, y positive. Case 2 is what? It is case 1. Case 2 is what? X is negative, y is negative, and their product is also positive. If both are positive, result is positive. Both are negative, result is positive. In Boyle's law, what happens? Volume is positive and pressure is positive. So graph is here. There is no volume and pressure cannot be negative quantity. So the graph in this third quadrant it is not possible. Now look at this thing again. I am telling you what. Now y is equal to 1 by x. The graph, when x increases, suppose this is x-axis, this is y-axis. When x increases, the value of y decreases. X increases, y decreases. X decreases, y increases. When it is in first quadrant, the graph is like this. When it is third quadrant, the graph is like this. Look at this picture. When x tends to, what is this point? This point is what? limit of y means 1 by x, when x tends to 0 plus. When x tends to 0 plus, the value of y is what? Infinite. When x tends to 0 minus means it is just on the left of 0, and the value is what? 1 by x is equal to minus infinite. So limit of x tends to 0 plus of 1 by x is not equal to limit x tends to 0 minus of 1 by x. Hence limit x tends to 0 1 by x does not exist. But many students think that limit of 1 by x tends to 0 is equal to infinite, which is clearly wrong. So x tends to 0 means x tends to 0 plus or x tends to 0 minus. In that concept, we'll read two things. This thing, number 6 and number 8. Number 6, you note down this graph, which is very important. For this, you have to read the book Play with Graphs by Aryan Publication, which is very, very important in your life. Now, see the graph up. See the problem number 6, limit x. Sorry, here you have to write the definition again. A function fx is continuous at x is equal to 0 if limit, it is definition 1, 0 plus of fx is equal to limit x tends to 0 minus of fx is equal to f0. It is right hand limit, it is left hand limit. And now limit x tends to 0 plus fx. Limit x tends to 0 plus x. What is the meaning of x tends to 0 plus? X tends to 0 plus, it means x never equal to 0. As x never equal to 0, what is fx? It is simply sine 1 by x. Tell me, when x tends to 0 plus, look at the graph, x tends to 0 plus, limit x tends to 0 plus of 1 by x is infinite. And the value of sine infinite is what? The value of sine infinite is the value which we do not know, because it lies in between minus 1 to 1. Suppose at a point a pendulum oscillates like this. If I will tell where is the position at a point, at a fraction of second, it will not staying at that point, it will leave that place. So limit of sine 1 by x tends to 0 plus, it has no particular value or lies in minus 1 to 1. No particular value. Similarly, it is right hand limit. What is left hand limit? Limit x tends to 0 plus 0 minus fx is equal to limit x tends to 0 minus of sine 1 by x. It is also, the graph is what? Here I am telling you this point. Here limit x tends to 0 minus of 1 by x, it is minus infinite. It is sine minus infinite, means sine minus infinite, again a value which we do not know. It lies in between minus 1 to 1. So I am writing lies in minus 1 to 1. That is no particular value. No particular value. What is, this is right hand limit, this is left hand limit. What is the functional value? What is functional value? Functional value, here it is telling, it is f0. The value of the function when x is equal to 0 is what? It is 0. Now, right hand limit, no particular value. Left hand limit, no particular value. Functional value 0. Are they equal to each other? They will not equal to each other. Since here LHL, RHL, functional value are not equal to each other. So the function is not continuous at x is equal to 0. Now, after number 6, I will teach you number 8. Okay. Now, I will discuss number 8 after number 6 because they are in same method, same manner. 1 by x, x not equal to 0, x not equal to 0. Here I am telling it is a special case. Now, for number 8, the definition of a function fx is continuous at x is equal to 0 if limit x tends to 0 plus is the of fx is equal to limit x tends to a minus 0 minus of fx is equal to f0. It is in exam you may or may not draw this picture, this graph, but it is absolutely important thing. Here the graph. Here the graph of what? Y is equal to graph of, I am telling, graph of 1 by x. And when limit, here it is 0, limit x tends to 0, my 0 plus of 1 by x is what? X tends to 0 plus, value is infinite. And here when limit x tends to 0 minus of 1 by x, the value is what? Minus infinite. Now look at here. Limit, left hand limit. Suppose I am telling you the right hand limit. What is right hand limit? Limit x tends to 0 plus of fx. That is limit x tends to 0 plus. What is fx? You have to write e to the power 1. In the previous video, I have discontinued the number 8. Now I am again telling you the number 8 problem. Here the function, here 1 by x, the condition is 1 by x. So we have to apply the formula of the definition of continuity as limit function fx is continuous at x is equal to 0 if this right hand limit is equal to left hand limit is the formula, is the functional value. Now here is the graph of y is equal to 1 by x and the limiting value of 1 by x extends to 0 plus is infinite. Limit of 1 by x extends to 0 minus is minus infinite. Now I am telling you the problem of a right hand limit of the function fx. Limit of fx extends to 0 plus of fx. In place of fx you have to write e to the power 1 by x minus 1 by e to the power 1 by x plus 1. Now x tends to 0 plus. Look at here. X tends to 0 plus. 1 by x tends to what? 1 by x tends to infinite. If 1 by x tends to infinite, e to the power 1 by x tends to what? We know the value of a is 2.7. 2.7 to the power infinite. If we will take only 2 to the power infinite is infinite, then it is clearly infinite. And the value is what? Infinite minus 1 by infinite plus 1. I am giving one example. Suppose limit x tends to infinite. Suppose here t tends to infinite. T minus 1 by t plus 1. then it is what? Infinite minus 1 by infinite plus 1. Then we have to infinite minus 1. सपोज समुद्र में एक बाल्टी एक ग्लास पानी कौन ले गया तो बचा कितना? से इनफाइनाइट. सो इनफाइनाइट माइनस 1 इज इनफाइनाइट and infinite plus 1. Suppose one is giving one glass of water to the sea, so it will become that sea. So समुद्र में एक ग्लास पानी मिला लो कि एक ग्लास पानी उससे ले जाओ, वही बात ही रह जाएगा. So infinite minus 1 by infinite plus 1. Infinite minus 1 is infinite, infinite plus 1 is infinite, and limit of infinite by infinite, it is undefined. In that case, what we have to do? Limit t tends to, we have to do this. What is that? Limit t tends to infinite. We have to divide t here. It is 1 minus 1 by t by 1 plus 1 by t. If t tends to infinite, then 1 by t tends to what? If t tends to infinite, 1 by t tends to 0. You know it or not? Suppose 1 kilo chinapur, 1. If a person will eat, then 1 kilo. If 10 persons will eat 1 kilo chinapur, then it will be 100 gram. Each will get. If 100 persons will eat, then each one will get just 10 grams. If 1 kilo chanapada will eat by all Indians, then suppose all Indians I am writing is infinite, then each one will get a homeopathic tablet like. The value is what? It becomes 0. So 1 by infinite tends to 0. You know it by this example. So in this case, what we have done? We divide the t, the value of t. Here it is t, here t. Highest power t to the power 1, t to the power 1. So we divide that t to the power 1 to both sides. Here what we have to do? Suppose e to the power 1 by x. It is infinite. Minus 1 by infinite plus 1 like this. So what we have to divide? We have to divide e to the power 1 by x to numerator and denominator. 1 minus 1 by e to the power 1 by x divided by 1 plus 1 by e to the power 1 by x. Then tell me what is the value? Now if e to the power 1 by x tends to infinite, then e to the 1 by e to the power 1 by x tends to what? I am writing it again. 1 by e to the power 1 by x tends to what? E to the 1 by e to 1 by infinite. 1 by e to the power 1 by x means 1 by infinite. 1 by infinite, you know it tends to what? 0. So it is 0 and it is 0. And the result is what? 1. So its value is 1. What is left hand limit? Left hand limit, limit x tends to 0 minus of fx is equal to limit x tends to 0 minus fx means e to the power 1 by x minus 1 by e to the power 1 by x plus 1. Look at here. X tends to 0 minus. This part is here. X tends to 0 minus. 1 by x tends to, look at here. X tends to 0 minus. Matlab x is on the left of 0. The value is what? 1 by x is minus infinite. And e to the power 1 by x tends to e to the power minus infinite. That is 1 by e to the power infinite, that is 1 by infinite, that is 0. So its value is what? It is 0 minus 1 by 0 plus 1. The result is what? Minus 1. Now the right hand limit is plus 1, left hand limit minus 1. What is functional value? Functional value. Here it is functional value when it is f0. Means the value of the function when x is equal to 0 is what? Is 0. Now I will write what? Since right hand limit, functional value are not equal to each other, so the function is not continuous at x is equal to 0. Since LHL, RHL functional value are not equal to each other. So the function is discontinuous. I am not writing here, so you have to write. So the function is discontinuous at x is equal to 0. Next I will teach you the number 7, 9, 10. Now we will discuss the problem number 7. Here it is the bracket function number 7. So definition, a function in bracket function, you know what you will do. We will do left hand limit, right hand limit, and the number 7. A function fx is continuous at x is equal to minus 11 by 3 if limit x tends to minus 11 by 3 plus means right hand limit of fx is equal to limit minus 11 by 3 minus of fx is equal to at minus 11 by 3. It is right hand limit, it is left hand limit, that is functional value. Now I am writing right hand limit. What is that? Limit x tends to minus 11 by 3 plus of fx. As like the previous problems, what we will write? In place of fx, what we will write? 3x plus 11 bracket value. X tends to minus 11 by 3 plus means what? X is minus 11, x tends to minus 11 by 3 plus means it is slightly greater than minus 11 by 3. So x greater than minus 11 by 3. You don't think it is greater than minus 11 by 3 means it is 100, 200 like this. You should think it is a slight greater than minus 11 by 3. And 3x is slightly greater than minus 11. Here, if you add 11, 3x plus 11 greater than 0. Don't think it is greater than 0 means it is 5, 6 or 100 like this. It is just slightly greater than 0 means 0.1 or 0.2 like this. If it is 3x plus 11 is slightly greater than 0, then what is its bracket value? Look at here. What is its bracket value? I am telling you the graph like this. Here it is 0, here it is 1, here it is 2, here it is minus 1, like this. 3x plus 1 plus 11 bracket value. Here it is slightly greater than 0 means the position is here. If you will put a cycle ball, what will happen? It will just come and put on the hole 0. So value is 0. Now left hand limit. What is left hand limit? Limit x tends to minus 11 by 3 minus fx. What is this? It is limit x tends to minus 11 by 3 minus of what? 3x plus 11 bracket value. Here, look at here. X tends to minus 11 by 3 minus means x is less than minus 11 by 3. 3x is less than minus 11. 3x plus 1 plus 11 less than 0. Less than 0 means it is slightly less than 0. So I am putting a tick mark here. So if we put a cycle ball here, then what will happen? It will come to the hole of minus 1. Then what is the result? It is minus 1. Now, what is the functional value? Functional value means the value of the function at the point minus 11 by 3. And here fx is equal to 3x plus 11 greatest integer. So you put 3 into what? Minus 11 by 3 plus 11. Minus 11 by 3 plus 11. 3 cancel. It is minus 11 plus 11. It is what? it is 0. The bracket value is 0. Now, the right hand limit, left hand limit, functional value. Are they equal? It is here 0. The right hand limit 0. The left hand limit -1. The right hand limit 0. Are they three equal to each other? Absolutely not. They are not equal to each other. So, here the function is not continuous at x is equal to -11/3, which you will write. Now, we will discuss the problem number 9. Problem number 9. What is problem number 9? A function fx is continuous at x is equal to 0 if limit x tends to 0 minus is x tends to 0 plus limit x tends to 0 minus, here it is f0. What is right hand limit? Right hand limit, it is limit x tends to 0 plus of fx is equal to limit x tends to 0 plus. What is fx? Here it is fx 1 by x plus bracket x. Because, can you write this? No, it is wrong. Because x tends to 0 plus. Look at here. When x tends to 0 plus, that means x is greater than 0. If x greater than 0, so it is telling what? It is telling fx is equal to -1. So if we will put this, then it is wrong. It is wrong. Then what we will write? The limit x tends to 0 plus of fx is equal to limit x tends to 0 plus. As x tends to 0 plus means x greater than 0, in that place fx you will put -1 and the result is also -1. So the value of the right hand limit is what? The value of the right hand limit is now -1. Left hand limit. Limit x tends to 0 minus of fx is equal to limit x tends to 0 minus. What is fx? Now fx has two values. When x less than 0, this is this. When x greater than 0, this. I have taken in right hand limit x tends to 0 plus. I have written is fx is -1, not this one. Here x tends to 0 minus. What you have to write? Fx x tends to 0 minus. X tends to 0 minus means x less than 0. X tends to 0 plus implies x greater than 0. X less than 0, what you will put here? 1 by x plus bracket x. Now look at here. X tends to 0 minus. What is the value of x? Obviously it is 0. So it is 1 by 0 plus. When x tends to 0 minus, what is the bracket value? Now 0 minus, the bracket value of 0 minus is what? Tell me. This is my 0, this is 1, this is 2, this is 1, this is 0, this is -1. When x tends to 0 minus means here the position. When you put a cycle ball in this position, it will go to this hole, and what is that the result? The result is -1 plus the result is now -1. Entire result is what? -1. Here it is -1. Here it is -1. Don't think it is the function is continuous. Next we have to find the functional value. What is functional value? It is f0. What is f0? When x is equal to 0, when x greater than 0 or when x is equal to 0, the function, the fx is equal to what? -1. f0 is equal to -1. Since RHL, LHL, functional value are equal, so the function is continuous at x is equal to 0. The function is continuous at x is equal to 0. Here all the 1, 2, 3, 4, 5, these are the cases of bracket function, of modulus function, bracket function, modulus function, bracket function, and one, the special condition, 1 by x, x tends to 0 here and here. Now we will teach the number 10. Number 10, look at the number 10. What is that? Limit. Here the position x tends to 0 plus of fx is equal to, if x tends to 0 minus fx is equal to f0. Now we will find separately what is right hand limit. Limit x tends to 0 plus of fx is equal to limit x tends to 0 plus fx. What you will write fx? X tends to 0 plus. X tends to 0 plus. It means x never equal to 0. x का वैल्यू क्या है? 0 से थोड़ा ज़्यादा. It is a small value greater than 0. Means 0.1, 0.001 like this. So what we will write fx? In place of fx we will write mod x by x. Then limit x tends to 0 plus. Try to remember the definition of mod x. What is mod x? Mod x, x if x greater than or equal to 0, minus x if x less than 0. X tends to 0 plus. X tends to 0 plus means x tends to 0 plus means x greater than 0. So in place of mod x, what we will write here? We will write mod x, x greater than 0. What is the value? X. X by x. It is 1. Why x by x 1? If we will put 0, then it will become 0 by 0. 0 by 0 is undefined. But you can't put 0 here because x tends to 0 means x not equal to 0. You cannot put 0 here. Next, left hand limit. Left hand limit. Limit x tends to 0 minus of fx is the limit x tends to 0 minus fx means mod x by x. It is limit x tends to 0 minus. What is mod x? Mod x. X tends to 0 minus. X tends to 0 minus means x less than 0. When x less than 0, mod x is what? Minus x by x. And the result is what? Minus 1. Here the right hand limit is plus 1. Here the left hand limit is minus 1. What is the functional value? Functional value means f0. f0 is what? f0 is 0. Now the functional value is 0. Since left hand limit, since right hand limit, left hand limit, functional value are not equal to each other. So the function is discontinuous. Here I am telling you an interesting graph of this problem. Look at here. When x greater than 0, the value is what? When x greater than 0, that is x tends to 0 plus, the value of the function is what? 1. Means like this. It is 1. When x less than 0, 0 minus, value is what? Minus 1. Look at here. I am not touching it in this place. I am not touching in this place. It is minus 1. The graph of this function is, look at me, graph of this function, when x greater than 1, it is plus 1. When x when x greater than 0, the value of the function is 1. When x less than 0, when the less than 0, the value of the function is minus 1. When x is equal to 0, the value of the function is 0. Here. So tell me, suppose one is drawing this picture. How that person will do the graph by pencil? Simply just draw a line like this. At this point, he must remove the pencil and put it a black spot here. Then go to this point, not touching there. He goes like this. So after this, he will go to this point. Then after that, he will go like this. So as that person removes her hand, so the graph is not in continuous manner. So it is a discontinuous function. Similarly, we can draw all the graphs, and on the next video we will discuss the problems. Sorry, it is not problem 9, it is problem 10, and we'll do the problems 11, 12 and onwards.